Thank you, and good afternoon. Welcome, everyone. So I'm going to give today an overview of the Yocto embedded framework. This is going to be mostly aimed at people that aren't familiar with the Yocto, haven't really used it, and want to know more about what it offers, what it provides, and how to get started. We've got a little bit less than half an hour, so I'm going to have to move pretty quickly to try and cover some of this big topic. So hopefully I have some time for questions at the end, depending on how the time goes. So we're going to take a look a bit at what Yocto is, why you need something like this, what it provides, what some of its benefits and advantages are, as well as some of its limitations. I'll talk briefly about the different versions of Yocto and some of the other framework options that you could look at in addition to Yocto. And then we'll look a little bit at the architecture, the major components of Yocto, and the basic steps that you'd be following to build an embedded operating system and SDK with Yocto. Focusing on things like the bitbake build system. I'll give a couple specific examples of how you could build OS images for an emulator and for a particular embedded board, and talk a bit about building an SDK, and then talk about how Qt is supported under Yocto. And then I'll give you some tips on doing a little bit more and some pointers on how to get started and some references that you may want to check out for more information. So Yocto really is a project for building custom Linux-based embedded systems. It's not a particular Linux distribution. It's really a tool for building Linux distributions that you customized. It's been around since 2010. It's an open source project, and it's managed by the Linux Foundation, the same as the Linux kernel. And it's a collaborative effort among a lot of people, ranging from individuals to corporate members. There's a number of sponsors, some of the larger software and hardware companies. So it's not just a particular embedded Linux distribution, but it's really a framework and an architecture and a build system to allow you to build your own customized embedded operating systems. The name isn't particularly meaningful. It actually comes from the metric prefix. It's the smallest metric unit prefix. Yocto of a unit is 10 to the minus 24. It's just a number that or a word that they liked for the name, so it doesn't really have any significance other than they thought it sounded good. So why do you need something like Yocto? If you've done desktop development, you'd be used to developing natively on a machine and running applications on the machine. But as you get into embedded development, it's significantly harder because you've got to get involved with cross-compiling for your target system. There's a much wider scope of what you need to cover, starting with things like a bootloader, the operating system kernel, device drivers, packaging formats, different utilities you need, and then one or more applications on your in your image, and then a software development kit. So it really has a lot of complexity as compared to, say, a native development process for native applications. So typically, you're developing on a desktop machine and then deploying that to an embedded device of some type. So if you've done any type of embedded development, it can be quite large when you're talking about building a kernel. All of the support libraries can be very time-consuming to build, and it can be error-prone, and you really want something that's repeatable and documented so that you can build your complete system in a known, repeatable way. There's also all of the different components can have different types of licensing, and it can be of interest to maybe not the developers, but the management, how the different software is licensed, making sure that you comply with licensing issues. So some frameworks like Yocto can help you manage that. It's also a reality today that you're going to need to update your embedded operating system or your application and libraries for security updates and other types of updates. So it's not going to be just a build once and then ship the product and leave it out in the field as is. So Yocto provides really a framework for building operating systems for embedded devices, specifically Linux systems. It targets all of the major architectures: ARM, PowerPC, MIPS, x86, 32 and 64-bit, and it's typically hosted on a Linux desktop, running any of the common Linux distributions like Red Hat or Ubuntu, for example. A major portion of it is the open embedded build system that uses the bitbake build engine, and we'll take a look at that. It also has support for different IDEs, and optionally, there's a graphical interface you can use to the build system. As the environment that it supports, it's been tested and certified on some specific Linux desktop distributions, but generally will work on just about any popular Linux distribution. So the main advantages are Yocto's really leveraging the work that other people have done so that you don't have to reinvent the wheel when it comes to building your own embedded Linux system. So it reduces the effort on your part, reduces the time, improves the quality of the end result, and helps you automate the building of your system so that it's stable and repeatable. So your builds can be automated and generated in a known way. It's also smart about things like caching information so that the builds can be incremental, and it makes it easy to update components for things like security fixes. And it's also free, as in both open source, and there's no runtime or other licensing costs. So it does have a few limitations. It's basically embedded Linux target only. If you want to develop for Android or Windows Embedded or some other RTOS like QNX, then Yocto isn't really designed for that. You're also going to need a reasonably high-end development system if you're going to be building the operating system on it. So you're going to want something with 4 gigabytes or 8 gigabytes, preferably, or more of RAM, 64-bit system, a few hundred gigabytes of storage, and reasonably fast internet connection to pull down all of the source code that you're going to need. As I mentioned, it doesn't dictate a particular embedded Linux distribution. You're really going to be building your own and customizing it yourself, but they do offer a reference distribution that you can start with. It's called Pokey, and that can be a good starting point to customize for yourself. So it's quite a large system. It's complex. It can have a bit of a learning curve, so it's something that takes time to get up to speed and get comfortable with. And it may be something where you want to have one or more people on your team specialize in the Yocto area of things so that not everybody has to be an expert in it. But it really pays off in the long run in the sense of being able to build your entire system from source in a known way that's repeatable and typically running on some kind of a continuous integration system. So really, its advantages have made it the leading framework for embedded Linux development. There's a number of versions out there. There's a table here. You'll hear different terms like Krogoth. That's referring to the code name for a particular Yocto release. You'll need to pick a release to work from. The choice is not necessarily going to be the latest release or the latest stable release. Sometimes it's going to be dictated by what your hardware vendor or your board support package supports. I think currently the commercial Qt for embedded or boot to Qt from the Qt company supports up to the Warrior release. And so sometimes it's dictated by what's available. The releases have both numbers and code names. And these code names, as far as I can tell, come from a real-time strategy game called Total Annihilation. And they also follow with a letter convention. So the most recent Zeus release just recently came out in the last couple of weeks, I believe. So that's sort of the latest and greatest at the moment. It probably isn't supported by a lot of the vendors yet. There are a few other options you may want to look at. Base Rock and Buildroot are a couple of other embedded frameworks. Crosstool NG are tools that help you build cross-compilers. These can be good if you're looking for something a little bit simpler. There's another option is many of the popular Linux distributions have embedded variants. So you could start with something like embedded Debian Linux. That's another option for an embedded operating system. The disadvantage of taking a desktop-type distribution is that tends to be larger, and you've got to go to a lot of effort to start stripping it down and taking out the things that you don't need. It may also not be optimized for the hardware architecture that you're using on an embedded platform. For example, in the Raspberry Pi, you might have heard of the Raspbian distribution where they customize Debian to build for with the right compile options for the Raspberry Pi architecture. So as I mentioned, Yocto tends to be probably the most commonly supported embedded framework from hardware manufacturers and operating system providers. So it's pretty common that if you buy a development board or go with a commercial product from somebody like Wind River that they'll provide images and Yocto recipes that you can use for their hardware. So there's a diagram here showing the overall architecture. We'll cover a little bit of this more in detail later. Essentially, source code for different components gets downloaded from what you could call upstream projects, or they could be local files or configuration management system repositories like Git. And these get cached locally so you don't have to download the same code every time you do a build. And the builds are also incremental, so it only really needs to build what's changed from one build to another. And the components typically start with things like the bootloader up to the Linux kernel, and then getting into libraries and applications. There's also a facility so that you can apply patches to source code when you're building it. It's pretty common that some packages need some patches if they're going to be cross-compiled for embedded systems. The original authors don't always set them up so that they'll build with a cross-compiler. You can also integrate QA tests like unit tests and run those as part of the build process. And then ultimately, you're going to get a operating system image, which will have a kernel and a root file system. And optionally, you'll likely be generating an SDK or software development kit. And we'll talk briefly about that, but that's a cross-compiler and the different development tools that you'll need to develop on a desktop. So this is all done by metadata in the form of different configuration files and scripts, and coordinated by the bitbake build system. So the major components of Yocto, bitbake is the one of the main components that you work with. It's the interface to the build system. It's taken from the Open Embedded project and uses scripts and configuration files called recipes. Another term you may see is Pokey, which is a reference Linux distribution that's offered that you can use as a starting point, or you may be given another distribution to start with from a hardware vendor like Wind River or Mentor. You can build for an emulator that will run on a desktop. It's a QEMU-based emulator, and that allows you to build an image that will run on an emulator, and you can run on the desktop if you don't have the actual hardware yet, and that can emulate either x86 or ARM-type platforms. I'll show a couple screenshots of that shortly. Toaster is a web interface that you can use to control the build system remotely through a web browser and do things like initiate builds from on a build server from a web browser and pull down the builds and see the results of builds that you've done. Yocto can build an SDK as a self-contained installer script that then you can give to developers, and they can use that to develop on desktop platforms. We'll look quickly at the steps involved in building that. But basically, an SDK is a tool chain for cross-development that gives you the compiler, debugger, and different miscellaneous tools. And things like header files for libraries and so on, including Qt if you're developing with Qt. In terms of IDE support, Yocto doesn't really dictate any particular integrated development environment, but there is a plugin available for the Eclipse IDE that's one option, but you can also use it with other IDEs like Qt Creator, and that works quite well. Finally, there's something called a build appliance. If you want to get started quickly, you can download a pre-built Linux virtual machine that has everything you need to get started for Yocto development. So that's a good way to get started quickly initially. So the basic steps that you typically follow to set up and do Yocto development is set up the tools on a Linux desktop host machine, and then configure bitbake for your particular embedded hardware platform. Then use it to build the software components, starting with the bootloader, the root file system, the kernel image. And once that's all built, then you typically write the boot image and the file system to your target hardware. You also want to set up your software development kit on a desktop system, and then at that point you can start developing and just repeating. So a bit about the bitbake build system. We talked a bit about that in an earlier slide, but these are sort of the steps that the bitbake system follows when you're building images. So it goes out and it fetches source code for the components from upstream projects, which can be direct downloads, or it can pull things down from mirrors or locally cached copies. And then it extracts the source code from whatever format you've downloaded it, things like tar archives. It can optionally apply any patches that might be needed for building it in a cross-compilation environment. Then it will run the whatever type of configure script or program is needed to build the software, and then does the actual building using the bitbake tool, using make or CMake or other tools are used for the particular software. It automatically does parallel builds based on the number of CPU cores that you have available. And then installs the software, packages it if you're using a packaging format, and ultimately you've got the software available to deploy to your target system. So typically you're going to have a operating system root file system and a kernel image that then you can write to your target system with flash or micro SD or whatever type of hardware it might use. So bitbake has got a defined directory structure for the metadata it uses, different types of configuration files and scripts. And this is a little complex at first to use, but the structure gets apparent after a while as you start working with it. There's configuration files, some of which are standardized, and there's some which are configured by the user. The major components are grouped into what they call layers, and there are a number of different directories that hold things like cache download files, packages that get generated, operating system image, things like that. So let's look at a specific example of how you could build the Pokey Linux distribution on a Ubuntu Linux desktop and run it on the emulator that's supported by Yocto. So you could do this on any Linux distribution, but if you're using, say, Ubuntu, I could show the steps here for that. Again, it's only supported on Linux desktops, but often people will run on top of a Windows or Mac OS environment using a Linux virtual machine. So there's a few dependencies needed. This lists here the development tools that you need on an Ubuntu system just to get started to run the Yocto and bitbake. So the next step would be pick a directory for where you want to work. I just called it Yocto here. Everything can be run as a regular user, and you can have different builds in different directories. You then want to download or check out from Git the Yocto version that you want to work with. In this case, I'm just downloading rather from Git, just downloading one of the releases that's available, the Warrior release. So that's available as a tar file that you can download and extract and go into the source directory for it. That's only about a 20 megabyte download. It's really just the framework and tools and scripts and not any of the actual source files that you need. That will come later. So typically then there's a script you need to source to set up some of the build environment. And then you're going to want to edit a file called local.conf that defines the hardware that you're building for. So if we want to build for the emulator, there's a line in there that specifies the machine, and one of the options is a QEMU ARM, which is the QEMU emulator version emulating an ARM. So we just need to change one line in the local.conf file. At that point, we could then run the bitbake command to build a basic core image for the Pokey Sato release. So that's this bitbake core image. Sato will build a complete image for Pokey Linux. So that's going to go through all the steps of fetching source code, extracting them, patching them if needed, configuring and building all the different components. And that's typically going to take a few hours the first time you do it, depending on the speed of your machine and the speed of your internet connection. But subsequent builds are going to take less time because a lot of that will be cached. So having done that, you can you'll have an image that you can then run in an emulator. Here's a couple screenshots of the QEMU emulator coming up. For the Poke Linux distribution, there's a kind of a minimal splash screen, and there's a very simple desktop that's provided by default with some tools like terminal emulator and a simple file manager and so on. This can be useful to get started. Here's a screenshot of running a console, and you can see some of the commands being run there like you would on the actual embedded system. So an emulator is a good way to get started. Often you don't have hardware when you're starting a project, but at some point you're likely to get real hardware, either the final hardware, or you may want to start with some type of off-the-shelf development board. So if we look at another example here, another popular development board that's popular for embedded development and it's reasonably low cost is the Beaglebone Black, one of the Beaglebone series. That's an ARM-based embedded board. And this is one of the platforms that's supported by Yocto. The steps are pretty much similar. You'd edit the local.conf file and set the machine, in this case, to Beaglebone Yocto, and then run bitbake again, and it will build an image for this particular board, including the bootloader. The Beaglebone, you can write the image to a micro SD card and then install that in the board and then boot it up. There's a little bit of work to format a micro SD card. It wants a couple of file systems for the bootloader and the Linux root file system, and this is all documented. You can pick up the details to it, but typically you're going to have to format the micro SD card on your Linux desktop and copy the relevant files to the micro SD card for the format that the Beaglebone wants to run. I listed a few commands here. So at that point, then you can put the micro SD in a Beaglebone card, hook it up to a monitor, keyboard and mouse, and boot it up and have a working distribution that you can start with. So for development, you need an SDK, and that's basically a cross-compiler, debugger, and some of the other development tools you need to develop on a desktop. It's what most of the developers will use if they're working on an application, and that could be built with bitbake using the relevant commands. So one of the things it understands here is an option to build an SDK for the particular image. So that, again, is something you can run, will go off and take some time to build. Ultimately, you get a very large shell script, the one listed here. And that's something that you can then give to developers, and they can install and run it on a Linux desktop to set up their environment. So I showed an example here of running that. It has everything needed, self-contained in the file that it will install locally on a Linux desktop. And you can either install it per user, or you can install it in a shared location for multiple developers to use. So once that's set up, there's a environment script you can run to set up the environment and set the paths and so on to use the cross-compiler. And I've shown a simple example here where I've compiled a little C++ program with the SDK, and you can just see that after being compiled that it's an ARM binary for the appropriate architecture for the system that we built the SDK for. So typically you'll configure your IDE, whether it's Qt Creator or whatever you use to use this SDK and build with it and then deploy to the target system and do debugging and so on. So a bit more about Qt. There are Yocto recipes for Qt 5. You typically add this Qt 5 meta layer to the list of layers that you build in your Yocto configuration. And then you can build packages like Qt base using bitbake and add them to your image. And there's also support for building a Qt toolchain. This is all kind of what I would call vanilla Yocto, everything open source. Another option is the Qt company offers their commercial Qt for device creation, also known as Boot to Qt. That's also a Yocto-based Linux distribution. And that's another option, is to use Boot to Qt, and it has a similar environment, but it's pre-set up to support a number of different boards out of the box, like Raspberry Pi models and Beaglebone Black and some Toradex and other boards. So here's an example. If you wanted to use boot to Qt on a Raspberry Pi, you can clone the meta boot to Qt layer from the Qt project and set up the environment and build it for in this case, a Raspberry Pi 3, and run bitbake and ultimately get an image that you can write to a micro SD card. So a little bit more about bitbake. It's a Python-based system that has Python and shell scripts, and it's got a kind of a meta language that supports variables and things like that. So you'd be typically writing or adapting these bitbake recipes to build different components of your system. So typically you'd be writing what they call Yocto recipes, which would be these shell scripts and Python scripts. Typically writing new recipes for components like your own application or modifying components to configure things the way you want. So this is documented pretty well in a standardized format. You can start with templates to build recipes for your own software. So there are some good tutorials and more detailed documentation. This Yocto quick build is a good reference to get started that covers a lot of what I showed here in the presentation, how to build for a number of common boards. And it's a good first step to do something like this, get the Yocto running on a standard board like a Raspberry Pi or a Beaglebone Black. There's also consulting companies like ICS that can help you get up and running quickly with Toradex on your hardware, configuring Qt if needed, and document the build process for you and create SDKs and so on. So a few references to help you. There is a printed book here, the Rudolf Streif book that came out a little over a year ago, so it's pretty up to date. I would recommend that as a good reference if you like printed books. It's also available in ebook format. That's a good way to get information. There's a lot of documentation at the yoctoproject.org website. I've listed also here the Qt meta layers for building Qt under Yocto, and as well as the Raspberry Pi platform, and also that quick start document that I was talking about. So hopefully they gave you some insight into what Yocto does and why you'd want to use it and how to get started. And if it's a good fit for what you want to do, I'd encourage you to give it a try and use it for your projects. So I think we got a couple of minutes for questions. If there are any, I can try to answer them.
How hard is it to bring support to a new hardware platform, like, for example, the NVIDIA Jetson Integra SOCs, which up to now, as far as I can tell, have pretty appalling Yocto support? How feasible is that? I was told once by a self-appointed embedded evangelist, as he calls himself, that it's as easy as putting some device trees, but I wasn't too convinced about this answer. I would like to have your opinion on that.
Okay, it really varies. In the best case, your hardware vendor may provide pretty complete Yocto recipes that you can use, but that isn't always the case. If not, then that gets kind of an order of magnitude harder. You really need either to build up some expertise in Yocto or find somebody in your organization that can understand both Yocto and things like kernel device trees, what those are, which means nothing to like the application developer. So it can get challenging, quite time consuming to figure out all the right kernel options. And
yeah, I think we're kind of, I think we're just coming up to time now, so just a quick answer.
Yeah, then I think they would be more just the kind of the learning curve of Yocto, which it can take some time, but it pays off in the longer run if that's something you're going to do. A number of companies may choose to contract this out and let someone else do that type of work if something where they don't want to build the expertise in-house.
Yes, thank you very much,
Right.
Mr. Tranter.
Thank you.